We hired a team to do finite element analysis on our design. Do we still have to test? Let's talk about ways we can use finite element analysis in design and why we may still want to test it after this brief introduction. Hello and welcome to Quality During Design, the place to use quality thinking to create products others love for less. My name is DIANNA. I'm a senior level quality professional and engineer with over 20 years of experience in manufacturing and design. Listen in and then join the conversation at qualityduringdesign.com. What is finite element analysis? Just a brief background without getting into a lot of the complicated mathematical stuff. Finite element analysis is basically a digital prototype. Our inputs are a detailed part geometry and its material properties, and the other input is the operating conditions. Depending on the software that we're using for finite element analysis, our inputs can be probabilistic, meaning we have a distribution of different operating conditions, or they could be deterministic, where we just have a value. The output of finite element analysis is the digital prototype that can predict the behavior and performance of our design. The baseline outputs that we probably aren't going to see is a grid with displacements and rotations on points along the grid, and that was determined from our inputs. From those point-based displacements and rotations, the software can calculate things like stress and strain and forces. Things like harmonics, residual stresses, vibration, and temperature. And we may get a contour plot, which is a heat map showing areas of high stress or strain. Finite element analysis sounds like a designer's dream. We can have a digital prototype of our part and tweak different things about it, its geometry, its thickness, its material properties, and see how that affects how our product design might perform in whatever environment that we specify. And finite element analysis can help us during design, but just like other probabilistic and mathematical methods of design analysis, we need to understand the underlying assumptions of using any of these models to estimate our product performance. And it's best if we verify the results with actual test data. Our finite element analysis needs some sort of verification through test that the virtual prototype matches real-world conditions. This is not my story, but another person told me of a story about finite element analysis during new product design. The design engineer used finite element analysis to make design decisions, and the design engineer was thinking that because he had done finite element analysis, that the team didn't need to do any kind of testing. But the reliability engineer wanted to test the design anyway, using the standard recipe that the company had developed for these kind of parts. The results of the finite element analysis didn't line up with the results of the real-world testing, and retesting and redesign needed to happen. I've heard and seen of many stories like this, and the lesson out of these stories is that we need to verify the results of the finite element analysis with testing. Over years of use and many practitioners using it, we know that finite element analysis isn't a substitute for test. If this is the case, what can we use finite element analysis to do for us during the design process? Well, there are actually lots of ways we can use finite element analysis. Let's get into 3 of them today. One way we can use finite element analysis is to reduce our prototype iterations, so we can find limits in the design margins of our product, whatever it is we're designing, and that will help us reduce how many bad surprises we get at test. This is especially useful if we have a catalog of standard parts or similar parts. We can develop recipes of finite element analysis load cases associated with reliability tests that we have for those standard parts, and we can use those together to create a minimum design case for reliability. Another way we can use finite element analysis to reduce our prototype iterations is to run scenarios of different design options. and let the finite element analysis help us make some of those macro decisions about the design. Another way we can use finite element analysis during design is to help us plan for test. If we have the digital prototype and the contour plot and the heat map, that will give us some indication where to place sensors on our part when we are testing, or where we can design the test to focus the stresses on the part. Having the results of the finite element analysis may also help us to identify the possible limits of our design for test, what stresses and strains we should be targeting for our test. And then the final way that I'll talk about today that we can use finite element analysis during design is for a root cause analysis. And this story is from my experience. I was working with an engineer who hired a third party to perform finite element analysis for a plastic injection molded part to help us with a root cause analysis. An unexpected failure happened during a routine test. Why did it fail? The concern was that there was residual stress in the part. And this would be due to how the part was designed and the way the plastic flowed into the mold and was cooled. Whatever we found in the finite element analysis, we still tested to verify the results. Finite element analysis doesn't have to be a once and done either. It can be iterative. During the design process, we learn more about the product as we develop it. We can apply what we learn to the finite element analysis model iteratively through the design process if it helps us make decisions. Now, finite element analysis is costly. I've read that it could be in the tens of thousands of dollars. This is when we may want to consider the risk of failure. If the risk of our product or our design failing is high, it may justify the cost of finite element analysis. So this could be a risk-based tool that we can use to help us make better decisions for a safe product. So what's today's insight to action? Finite element analysis may help us during design. It is using mathematical models, and we need to understand the assumptions of those models when we're using the results of finite element analysis. It's best if we verify the results of the model with actual tests. We can first talk with our quality or reliability engineer on our team about which parts seem to carry the highest risk. That may indicate which parts we might be able to use for finite element analysis. And then we can talk with our reliability engineers about how to incorporate finite element analysis not only into the design, but also into the product test. But we can use finite element analysis iteratively to help us reduce our prototype iterations, to plan for tests, and even for root cause analysis. If you like the content in this episode, visit qualityduringdesign.com, where you can subscribe to the weekly newsletter to keep in touch. This has been a production of DIANNA Enterprises. Thanks for listening.